Hi, this is Miss Horton Russian, and this is Cosmetology 1000, Basics of Chemistry. So our learning objectives for this unit will be list the differences between organic and inorganic chemistry. So you can go ahead and take notes while you go through this. It'll be a lot easier to answer your questions or do whatever you need to do at this end of this video. Also, categorize and give examples of different substances for each of the different states of matter, solid, liquid, and gas. Summarize in your own words oxidation, reduction, reactions. Also, define the differences between pure substances and physical mixtures. Evaluate the differences among solutions, suspensions, and emulsions. Explain what pH is and how the pH scale works. Without an understanding of basic chemistry, you would not be able to use the professional products effectively and safely. So this is why chemistry is really an important area for cosmetologists or nail technologists. Every product used in the salon and in cosmetology services contains some type of chemical. With an understanding of chemistry, you will be able to troubleshoot and solve common problems you may encounter with chemical services. So knowing a little bit about chemistry is going to help us to troubleshoot problems that come up in the salons. Most cosmetology services depend on the use of chemicals, and most of our services do depend on chemicals of some kind. Studying the basics of chemistry means that you will have the knowledge you need to understand and the products that you are using to understand the products you are using in the salon to give your clients the professional services they deserve. So chemistry is the science that deals with the composition, structures, and properties of matter and how matter changes under different conditions. That's what chemistry is. It deals with the composition, structures, and properties of matter and how matter changes under different conditions. And we'll be talking about a little bit of it. Organic chemistry is the study of substances that contain the element carbon. So that's what organic chemistry is. It's the study of substances that contain the element carbon. All living things or things that were once alive, whether they are plants, animals, they contain carbon. All hair products, chemical texturizers, shampoos, conditioners, styling aids, nail enhancements, and skincare products are organic chemicals. So all of those are organic. Anything plant or animal is an organic chemical. Comes from organic. Inorganic chemistry is the study of substances that do not contain carbon. The element carbon may contain the element of hydrogen. Metals, minerals, glass, water, air, pure water, oxygen, hydrogen peroxide, hydrogen hair relaxers, titanium dioxide, and zinc oxide in sun protection creams are inorganic substances. So know the difference between organic and inorganic substances. So you can rewind the video if you need to. Any substances that occupy space and has mass, that's what matter is. Any substance that occupies space and has mass, has weight to it, is matter. All matter has physical and chemical properties and exists in the form of solid, liquid, or gas. All matter has physical and chemical properties and exist in the form of either one of these, solid, liquid, or a gas. Since matter is made up from chemicals, everything made out of matter is a chemical. So everything that's made out of matter is a chemical. An element is the simplest form of chemical matter. So if they ask you what is the simplest form of chemical matter, it's elements. It cannot be broken down into a simpler substance without a loss of identity. So which one of the categories that we're going to be talking about, molecules, atoms, elements, cannot be downsized without changing it. It changes it. It's not the same element because elements have certain, they're identified by letters and symbols. So if you try to simplify them and try to break them down, you are going to change. It's not going to be the same element. It's going to be a different element. All matter in the universe is made up of these elements, and they have their own distinct physical and chemical properties. Each element is identified by a letter symbol, such as O for oxygen, C for carbon, H for hydrogen, N for nitrogen, and S for sulfur. Composed of a single part or unit. So it's composed of a single part or unit. It cannot be reduced to a simpler substance, at least not without the loss of its identity. Okay, there are 98 natural occurring elements. How many are there? 98. 98 natural occurring elements. Atom. The basic unit of matter with a nucleus at the center surrounded by negativity charged electrons that move around the nucleus in the orbits. The nucleus consists of protons, subatomic particles with a positive charge, and neutrons, subatomic particles with no charge. And the number of protons determines the element. So however many protons they have, that determines what element it is. Atoms cannot be divided into simpler substances by ordinary chemical means. Molecules, a chemical combination of two or more atoms in definite fixed proportions. That's what a molecule is, a chemical combination of two or more atoms in definite fixed proportions. For example, water is made from hydrogen and oxygen of the same portions. Elemental molecule, a chemical combination of atoms of the same element in fixed proportions. The air we breathe is an elemental molecule. O2, the ozone in the atmosphere is an elemental molecule. O3. Compound molecule. Compound molecule, these are chemical compounds of two or more atoms of different elements in fixed proportions. So compound molecules are different elements in fixed proportions. Sodium chloride, NaCl, or common table salt is a compound molecule that contains one atom of sodium and one atom of chloride. So NaCl, or common table salt, is a compound molecule that contains one atom of sodium and one atom of chloride. So just kind of look at this chart for a minute. All matter exists in three different physical forms: solid, liquid, or gas. Matter takes one of these forms or states depending on its temperature. Solids have a definite shape, volume, and weight. You got to know that. Liquids have a definite volume and weight, but not a definite shape. Water takes on the shape of its container. Gases do not have a definite volume or shape. Neon or argon are two different gases. Make sure that you know examples of these also. Vapor is a liquid that has evaporated into a gas-like state. Vapors can return being a liquid when they cool to room temperature, unlike a gas. Steam is an example of a vapor. Vapors are not a unique state of matter. They are liquids that have undergone a physical change. So vapors are not a unique state of matter. They're not a matter. They are liquids that have undergone, so they're part of the liquid department, that have undergone a physical change. Physical properties are characteristics that can be determined without a chemical reaction, and they do not involve a chemical change in the substance. Include color, solubility, odor, density, melting point, boiling point, hardness, and glossiness. So it can have all those properties, okay, when its physical properties change. Chemical properties, these are characteristics that can only be determined by a chemical reaction and a chemical change in the substance. Examples could include the ability of iron to rust, wood to burn, or hair to change color through the use of hair color and hydrogen peroxide. Matter can be changed in two different ways. Physical forces cause physical changes, and chemical reactions cause chemical changes. A physical change changes the form without forming a new substance. So if you have a physical change, it changes the form without doing a new substance. An example, solid ice melts and becomes water. There are no new chemicals, just a different form. A chemical change is a change in a substance chemical composition. A chemical change creates a new substance with different properties. Examples, iron to rust, wood into ashes. the oxidation of hair color, or the polymerization of artificial nail enhancements. All those are chemical change. Oxidation, make sure you know this, is a chemical reaction that combines a substance with oxygen to produce an oxide. So oxidation is a chemical reaction that combines a substance with oxygen to produce an oxide, such as the oxidation of melanin pigments in hair by hydrogen peroxide in lightning processes. Oxidation reduction, also known as redox, a chemical reaction in which oxidation and reduction takes place at the same time. So that's what oxidation reduction is. It's where it oxidizes and does a reduction process all at the same time. In an oxidation process, you add oxygen, you minus hydrogen. In the reduction process, you minus oxygen and you add a hydrogen. Two different processes. An oxidizing agent is a substance that releases oxygen. Hydrogen peroxide is an oxidizing agent. Make sure you know that. Can be thought of as water with an extra atom of oxygen. A reducing agent is a substance that adds hydrogen to a chemical compound, or subtracts oxygen from the compound. So a reducing agent is a substance that adds hydrogen to a chemical compound or subtracts oxygen from the compound. So I want to go back here to read this slide one more time. A chemical reaction in which oxidation and reduction takes place at the same time. Now, exothermic reaction is a chemical reaction in which exothermic reaction is a chemical reaction in which heat is released. An example of an exothermic reaction is a nail product that hardens, polymerizes to create nail enhancements. That's an example of it. Combustion, the rapid oxidation of a substance accompanied by the production of heat and light. That's combustion, where it produces heat and light. Pure substances, a chemical combination of matter in definite fixed proportions. That's a pure substance. Definite mixed, a chemical combination of matter in definite mixed proportions is a pure substance. Pure substances have unique properties. Aluminum foil is an example of a pure substance. Make sure that you know the example. It has only atoms of the element aluminum. Physical mixtures. Physical combination of matter is in any proportion. The properties of a physical mixture are the combined properties of the substances in that mixture. Salt water is a physical mixture of salt and water in any proportion. It's salt water. That's a physical mixture. Solutions, suspensions, and emulsions are all physical mixtures. A solution is a stable physical mixture of two or more substances in a solvent. So a stable physical mixture of two or more substances in a solvent is a solution. A solute is the dissolved substance in that solution. So whatever dissolved in that solution is called the solute. And then the solvent is the substance, usually liquid, which dissolves that other substance, okay, to form a new solution with no change in the chemical compositions. For example, when sugar is dissolved into hot water, the sugar, a solid, is the solute, and the water is the liquid in the solvent. Water is the universal solvent. Make sure that you know that. Water is the universal solvent. Miscible liquids are mutual soluble, meaning that they can be mixed together to form clear solutions. Water and alcohol are examples of miscible liquids, as in a nail polish remover. When these substances are mixed together, they will stay mixed, forming a solution. Immiscible liquids, not capable of mixing, forming a solution. They're not capable of mixing, like oil and water. That's an immiscible liquid. And then suspensions Suspension are unstable physical mixtures of undissolved particles in a liquid. So they're undissolved particles. Emulsion, an unstable physical mixture of two or more immiscible substances that normally will not stay blended, plus a special ingredient called an emulsifier. So an emulsion is unstable. It's an unstable physical mixture of two or more immiscible substances. Emulsifier is an ingredient that brings two normally incompatible materials together and binds them into a uniform and fairly stable blend. Emulsions are considered to be a special type of suspension because they can separate, but the separation usually happens very slowly and over a long period of time. Now, surfactants are substances that allow oil and water to mix or emulsify. They are one of the type of emulsifier. The term surfactant is a contraction for surface active agents, substances that allow oil and water to mix or emulsify. The head of the surfactant, which is called the hydrophilic, you'll see it, the first word at the top on the screen, or water loving and dissolving in water. Okay, hydrophilic is water loving. The tail of the surfactant is the lipophilic, you need to know these, or oil loving and dissolves in oil. Okay, so the tail is the lipophilic, the head is the hydrophilic. Hydrophilic is water loving. Lipophilic dissolves in oil or oil loving. Oil and water emulsion. Oil droplets are emulsified in water. The droplets of oil are surrounded by surfactant molecules with their lipophilic tails pointing in and their hydrophilic heads pointing out. Tiny oil droplets form the internal portion of each oil and water emulsion because the oil is completely surrounded by water. Water and oil emulsions is the water droplets are emulsified in oil. So water and oil is those droplets are emulsified in oil. The droplets of the water are surrounded by surfactants with their hydrophilic heads pointing in, and their lipophilic tails pointing out. Tiny droplets of water form the internal portion of the water and oil emulsion because the water is completely surrounded by oil. You need to make sure that you know those two and what they do. Okay, so just look at this chart for a minute. Differences among solutions and suspensions. So miscible, slightly miscible, or immiscible. Emulsions are immiscible. Suspensions are slightly miscible. No surfactant. Suspensions don't have a surfactant, but emulsions do. Okay, the largest particles are in the emulsions, not the suspensions. The suspensions are usually cloudy, and the emulsions usually have a solid color. And then suspensions, nail polish, glitter, that it's in nail polish, that's suspensions. And emulsions are like shampoos, conditioners, hand lotions. So you can do this at home. Just take a glass of water and pour water into the cup and then pour a little bit of oil. And I think we've all seen it if you're cooking or anything, how the little oil just kind of goes up to the top. Okay. Stir the water briskly with a spoon and observe it for a minute or two. What does the oil do? So kind of look at it, see what the oil does. Ointments. Ointments, pastes, pomades, and styling waxes are semi-solid mixtures made with any combination of petroleum jelly, oil, and wax. Powders are physical mixtures of one or more types of solids. Off the scalp powder hair lighteners are physical mixtures. These mixtures may separate during shipping and storage and should be thoroughly mixed by shaking the container before you use it. So whenever you use powders or anything, you kind of shake it. Make sure, because it can separate. Or if it's old and sitting on the shelf. Volatile alcohols evaporate easily. Examples are isopropyl alcohol, rubbing alcohol, and ethyl alcohol, hairspray, and alcoholic beverages. Okay, those are volatile alcohols, and they evaporate easily. Alkanolamines are alkaline substances used to neutralize acids or to raise the pH of many hair products, often used in place of ammonia. Colorless with a pungent odor, so they have a major odor, and you've smelled ammonia. It has a tremendous odor. So ammonia is colorless with a pungent odor composed of nitrogen and hydrogen in a water solution. It is called ammonia water. Used to raise the pH, potential hydrogen in a permanent waving, hair coloring, and lightening substances. Raising the pH softens and swirls the cuticle, allowing solution to penetrate the hair shaft. And a lot of times if you have somebody that's come in with gray hair and it's very resistant, and they tell you that, my hair usually has a hard time taking, sometimes you can just use some peroxide and put some peroxide on it, and that will open up the cuticle so that you can go ahead and do the process. So glycerin, sweet, colorless, oily substance used as a solvent and moisturizer. Silicone is a special type of oil used in hair conditioners, water-resistant lubricants for the skin, and nail polish dryers. They are less greasy than many other oils and can impart a silky, smooth feel to skin and give hair a shine. Volatile organic compounds are compounds that contain carbon, organic, and evaporate very easily. The most common volatile organic compound used in hairsprays is ethyl alcohol, ETHYL, ethyl alcohol. It's most common used in hairsprays. All right, an ion is an atom or molecule that carries an electrical charge. That's what an ion is. It carries an electrical charge. Okay, it's an atom or molecule that carries an electrical charge. That's an ion. And ionization is the separation of an atom or molecule into positive and negative ions. So when they separate, that's called ionization. An anion is an ion with a negative electrical charge. And a cation is an ion with a positive electrical charge. Make sure that you know all those. In pure water, some of the water molecules naturally ionize into hydrogen ions and some into hydrogen ions. The pH scale measures those ions. The hydrogen ion H+ is acidic. The hydrogen ion OH is alkaline. Only aqueous solutions have pH. Non-aqueous solutions, oil and alcohol, do not have pH. Without water, there is no pH. Pure water contains the same number of hydrogens. Pure water contains the same number of hydrogen ions as hydroxide ions. It is neutral, being 50% acidic and 50% alkaline. The pH scale. The abbreviation used for potential hydrogen is, of course, pH, a measure of the acidity and alkalinity of a substance. That's what the pH is. It measures the acidity and the alkalinity of a substance. A scale of 0 to 14 indicates a neutral solution. Okay, so and why is this important? I mean, why is pH important? Well, because the pH, let's just talk about perms here for a second. if you're going to do a perm on somebody that's hair is very, it absorbs very quickly, you may not want to use an alkaline perm. If you use an alkaline perm on somebody who absorbs very quickly, who's not resistant, it'll be too strong for them, and then it'll cause frizzing or overprocessing. But if you use an acid perm on somebody that's hair is very resistant, it may not even take. So you have to know what you're using and what their hair is, so you use the right thing. So knowing the pH scale is very important. You know, they used to tell people after a perm, don't wash your hair for, or shampoo your hair for 24 hours. So they used to tell them after a perm, do not shampoo your hair for 24 hours. And people used to think, oh, because the curl doesn't hold. Well, that's not true, because once you neutralize that hair, if you do the process right, it is neutralized. The curl is locked into the hair. Their hair's not doing anything. The problem is when they go home and use shampoos with a higher pH, because some of the shampoos that we use off the market is a 13, and that's high acidic. And so it'd be just like putting another perm on their hair. So it would make their hair very dried out. So they tell them to wait 3 days. That's why they told them. Lo and behold, we never knew that, right? So below 7 indicates an acidic solution. Above 7 indicates the alkaline solution, okay? The logarithm, which is in multiples of 10, logarithm in multiples of 10, means multiples of 10. The pH scale is the logarithmic, because a change of one whole number represents a 10-fold change in pH. A change of 2 whole numbers represent a change of 10 times 10, or 100-fold. Okay, so it's very important. Each one of those are like multiples of 10. So the pH just gets higher and higher. And you can see the hair and skin here is at a 5. Okay, so if you're using harsh shampoos on your hair and they're acidic, it's like doing something to your hair all the time. So you want to be very careful that you use something that's around 7 and 8, so that it's not damaging to your hair. All acids owe their chemical reactivity to the hydrogen ion. Acids have a pH below 7.0. Alpha hydroxy acids are derived from plants, mostly fruit, are examples of acids often used in salons to exfoliate the skin and to help adjust the pH of the lotion, conditioner, or cream. Thioglycolate acid is a colorless liquid or white crystals with a strong, unpleasant odor that is used in permanent waving. You need to make sure that you know these also. And it's used to contract and close the hair cuticle. So thioglycolate acid is used to close the cuticle. It's strong, unpleasant smell, and it's usually a colorless liquid, usually. Glycolic acid is an alpha hydroxyl acid used in exfoliation and to lower pH of products. Glycolic acid is used to lower the pH of products. And then thioglycolic acid is used to contract and close the hair cuticle. All right, acids and alkalis owe their chemical relativity to the hydroxide ion, OH. This term is interchangeable with base. pH above 7, okay, is alkaline. Feels slippery, soapy on the skin. So if you ever notice something that's kind of slippery and kind of feels soapy, it means the pH is above 7. Sodium hydroxide, also known as lye, is used in chemical hair relaxers, callus softeners, and drain cleaners. Okay. So I want you just to kind of research maybe some of the products that's used in the salon at Savannah Technical College. I'm not sure if they're still using the Paul Mitchell hair color. The sensitive, they use the sensitive relaxers. So kind of find out what relaxers they use, what products they use, and then find out what the pH of some of those are. Okay. So look at the shampoos that they use. Find out what the pH of those are. Okay, so information is available online to find out about that, the manufacturers, whoever manufactures it. It'll tell the pH and stuff. So kind of find out some of that information, and that'll be one part of your assignment for this, is to find out that information and then upload it into your assignment box that I'll give you along with the questions at the end of this video, okay? That way I know you watched the entire video. Honestly, that's why I usually put one little thing inside it. Okay, the same reaction that naturally ionizes water into hydrogen ions and hydroxide ions also run in reverse. When acids and alkalis are mixed together in equal proportions, they neutralize each other to form water. Neutralizing shampoos and normalizing lotions used to neutralize hair relaxers work by creating an acid-alkali neutralization reaction. Interesting, isn't it? Liquid soaps are usually slightly acidic and can neutralize alkaline, callous, softeners, residues left on the skin after rinsing. Whether you are studying the pH of products, redox reactions, suspensions, solutions, or emulsions, there is a lot to learn about how chemistry affects the products you use in the salon. Have a basic understanding of chemistry will help you use professional products effectively and safely in the salon. So the more that you know about the chemistry of your products that you're going to be using, the better off you're going to be using them. Plus, you can explain them to the clients a lot better if you know the pH of them and what they contain. The science that deals with the composition, structure, and properties of matter and how matter changes under different chemical conditions is called chemistry. Organic chemistry deals with all substances in which carbon is present, while inorganic chemistry deals with substances that do not contain carbon. Summary review. Matter is anything that occupies space and has physical and chemical properties and exists as a solid, a liquid, or a gas. Matter exists in the form of elements, compounds, and mixtures. Matter can be changed either physically or chemically. There are benefits. There are benefits for the client who takes advantage of the various salon services that use chemical products. While the use of chemical products has great benefits, we must always remember they create a potential for danger or injury as well. So we need to make sure that we are aware of all that. As a professional cosmetologist, your ability to stay informed about new developments and products and how to use them effectively and safely will greatly impact your success. It will. The more that you know about your products, your clients know whether you know about your products or not. So you need to know, if you use hair color, what's in your hair color? If you use different shampoos, why do you use that shampoo? Is it because it was on sale that week? Or do you have a reason why you use that shampoo? So know a little bit. And, you know, if you're not, your memory, you know, I can't remember all that, put it on little index cards. As long as they know that you can get to that information, you know it. And the more that you say it, the more that you'll know it. So talk about your products. So for the questions that you're going to answer, you're going to answer what is chemistry? Number 2, why is the basic understanding of chemistry important to cosmetologists? Number 3, what is the difference between organic and inorganic chemistry? Number 4, what is matter? 5, what is an element? 6, what are atoms? 7, explain the difference between elemental molecule and compound molecules. Give examples. 8, name and describe the 3 states of matter. So name them and then describe them. What are the physical and chemical properties of matter? Give examples. What is the difference between physical and chemical change? Give examples. That's why I told you to take notes. If you took notes, you're going to make this real quick. If you didn't take notes, you didn't listen to direction. Explain oxidation and reduction, number 11. Number 12, explain pure substances and physical mixtures. Give examples. What are the difference among solutions, suspensions, and emulsions? Give examples. Define pH and pH scale.